we'll discuss around AWS network architecture. Don't think too much about the network. Let's start the whole learning as a dummy. Like we'll learn through the unknowns and finally we'll create the architecture as an infra engineer. Hi, this is Ravi Shankar here and you're watching. Let's get into our discussion now. So before starting our discussion, let's have a plan together. Just like in our on-premise, we wanted to build one server in the cloud. So whenever I got to know about the cloud, everyone will say you will have your PC or system in the cloud. So in the similar way, we want to build one server in the cloud, just like creating one system or PC within your branch. Once we create that system, we'll try to connect to that with the help of a network configuration. So we'll start thinking from there to explore other options available in the cloud. Okay, now we have the plan and let's get into the decision. So what exactly we are going to decide? Like an on-premise engineer, with that approach, we'll go through the cloud concepts. So immediately our mind will start thinking over the plan, right? So before creating any system or bringing up one branch, we'll have some kind of decision. Like if you take the data center build, the first thing we'll see what is the IP address CIDR block required for the DCs or the offices. So similarly, in the cloud, we have VPC CIDR block. Then what we'll do, we'll segregate those IP CIDR into multiple subnets. So in the similar way, in the cloud also we need subnets. Then we'll plan around the network access list and the security groups rules. Like for example, if you're going to create multiple subnets, depends on your requirement, then you will plan for the firewall rules as well, and then you will create the network access list around that subnet. So in the similar way, we'll have NACLs and security group in the cloud. Similarly, you will start doing the routing plan around the subnets within the DC or to your office or to the internet. How exactly you are going to connect to it? Like for internet, you will need internet link, and for connecting to other branches in the offices, you need a MPLS link. In case if you want to connect securely with your partner, then you will establish the VPN links. So in a very similar manner, we'll have the route tables, the transit gateway route tables, then MPLS link like direct connect links. Since you have internet links, similarly we have internet gateway, NAT gateway, and then for VPN creating VPN connections, you need virtual private gateway in the cloud. Then if you want to establish connectivity between your offices, then you will go for peering in the cloud. So you can compare just like this. Once you have the IP address and the subnets, then ACLs, routing, then you will plan and assign the public IPs. Like usually you'll get it through the ISP, and then you will assign that IP address either to your external firewall or to your internet exposed web servers. In the similar way, in the cloud, you will go for the elastic IPs, which is nothing but a public IP. So those public IPs you can assign it to your systems in the cloud. Then you will start registering your public domain names. In a similar way, you can create your private domain names as well within your organization. So in the cloud, we have a Route 53 to create the DNS records, the domain names. You can create the public hosted zone or the private hosted zone. In a similar way, you can create it. Then once you have all these, you will think around the overall traffic flow management across the internet and intranet. Like for example, if you are going to create a single rack or multiple rack, so how the power feed, is it high availability? So what will happen to my partner if my primary link goes down? And how many data centers I can build around? And what is my DR? In the similar way, in the cloud also, you are going to create number of VPCs. Excuse me. So the traffic flow among those VPCs, how exactly you're going to arrive at the CloudFront, CDN type of traffic. So all those things you can typically compare what you have in your on-premise or in the data center. So now you're decided upon the CIDR block, subnets, ACLs, and the routing, and then you're publicly exposed web server or the domains, and you have registered the domains. Then you have planned around the overall traffic management. Now immediately you will start think over the comparison, right? Now you got the comparison over the concepts. Now how exactly it is going to happen in the cloud? So usually in your data center, the rack will be provisioned with the patching done to all the ports, and your power strips would be installed. And similarly, power supply for the entire rack will be provided. Then the entire data center would be secured with all standard necessary security requirements, starting from card swiping. Your cage will be locked, and only necessary people will be allowed, and you should have some prior approval to enter into your DC area. So all these things will be taken care. In the cloud, you no need to worry about those things. The power, the rack, and the security requirements, how exactly you are going to secure your premises, all those things will be taken care by cloud. So basically, it's infrastructure as a service. They are going to provide you the infrastructure. On top of the infra, you are going to build your own server, and you are going to build your own infra on top of their physical location or physical rack or hypervisor. Okay. Then what you will do in your data center, like you will start installing the switches, routers, firewalls, servers are installed. So in a similar manner, in the cloud, you're going to launch the software from the marketplace and install it under the EC2 instance. Then you will create VPC and all other stuff to support this. Then what are all things that will happen in the data center? Like once you have the routers, switches, network servers are installed, you will plan for the MPLS link connecting back to your other data center and offices. And to reach internet, you will opt for internet link. The similar way in the cloud also, if you want to access the internet, then you will create one internet gateway and attach your VPC. And then you can create a direct connect for a private secure connection to your on-premise. So these are all the things you can compare and conceptualize. And then configuration. Configuration wise, what are all the firewall rules and what is the router routing rules? Then in switches, what are the VLANs has to be enabled? All those necessary configure requirements will be done. The similar way in cloud also, you're going to design the whole environment, like how many VPCs, how the traffic flow is going to open. All these things will be sorry, designed and implemented. Okay, now what you did, like you have a plan, and once you have the plan, you just compare with your on-premise data center and how exactly the build is going to happen within the cloud. So all these theoretical things you just had an overview, right? So now we'll start with the trial and error approach, just like a dummy. Like you got the console access, now you don't know what to do. So let's launch an EC2 instance, that is a PC in the cloud. And then we'll start seeing, so what are all the things we need to learn from there. So if you try to launch the EC2 instance, this is the first thing you'll see in your mind. Like in the AWS cloud, you're going to launch one EC2 instance. This is a blind approach. But once you get into the console, if you want to launch an EC2 instance, all these things will pop up. So you need to select the VPC, you need to select the availability zone, and on which subnet you're going to fetch the IP for the system. So all these things you need to have an answer. If you compare the same thing to the data center, let's consider your availability zone as a building, and you will have multiple buildings. And if you want to launch subnets, like you want to install the racks, then you will install the rack in multiple buildings. Then you will have a connectivity back to back for redundancy purposes. So in a similar way, if you want to have achieve some redundancy, you can create the subnets in multiple availability zones, so that if one AZ fails, the other AZs will start supporting you. So At a high level architectural view, this is the thing to start with our trial and error approach. So don't worry, now we'll try to launch an EC2 instance and then we'll try to connect those so that we'll come to know about the VPC, subnets, route table, gateways, and why all these things are required when we try to launch an instance and to connect to it. So it's going to be continued. Don't miss the next series of this session. Thank you.